This is the final part of our practice quarterfinal, and what better way to end it off with this question called half-life. We have this isotope. Well, I don't know the name, but it has a half-life of 5 years. Luckily, we have 20 grams of it, so hopefully it decays pretty fast. We need to know the decaying rates. Now, anytime you think of half-life, one of these equations comes to mind. It's perts with a negative symbol. Why is it negative? It's negative because it's simply decaying. Another reason why it's perts is because the isotope continues to decay. If it says, it doesn't say continuously, but because we know that the isotope is decaying every time, every second, it is using pert. If I want to find the decaying rate, I need to establish what I know, P, R, or T. P is my original amount, which I can read here, is 20 grams. So I'm going to plug it in, 20 E. Well, I'm going to put the negative. I don't know R, because clearly that's what I'm looking for. So I'm going to put R right here. And then time. Do I find time anywhere? Yeah, there we go. 5 years. Now I'm going to put 5 here, but this should equal to something. Well, here's the fact about half-life. Half-life halves whatever you have originally. You had 20 grams, but you're going to cut it in half. 20 divided by 2 is 10. So you have your setup for the equation. You want to solve for R, so how are you going to do that? I don't like this 20. It's multiplying with the E, so I need to divide both sides by the 20. So I'm going to divide both sides by 20 like this. 20s cancel out, leaving me with E, negative R times 5 equals 0.5. Okay, that makes it less complicated, but then I don't like that E. What do I have to do? If I want to get rid of this exponent, I have to do this special thing. I have to take the ln of both sides. Why ln? Well, it's simply because it's E. Anytime you see E, you want to write ln on both sides. So you're going to write ln E to the power of negative R times 0.5 equals ln 0.5. If you remember anything about exponents, this is called the power rule. Power rule makes the exponent move to the front. That's negative R times 0.5 times ln E equals ln 0.5. Fun fact about ln of E, that's simply just 1. So you can kind of just forget it. You have this left for R. You don't like the negative, you don't like 0.5, so all you got to do is divide both sides by, I apologize, it should be just 5, not 0.5, because that's simply year. I want to get rid of the 5 as well as the negative, so I'm going to divide both sides by negative 5. And so I'm going to put that in my calculator. I'm going to put simply ln 0.5 and parentheses divided by negative 5. That gives me my answer, which is 0.138, but I can round it, giving me 0.14. Okay, so I officially have my rates. This leads us to part B. You're going to use the information in part A to solve for it. It's now asking us the new amount in 30 years, because maybe, who knows, you go in time and you want to see how much is left. You're going to use the equation again. Everything with half-life revolves around negative pert. So I want to declare what I have. I had 20 grams, so I'm going to put 20. I'm still going to keep E, and I'm going to use my new R, 0.14. So I'm going to put negative 0.14, and then my time. A lot of students like to do this. Oh, I see time, 5. I'm going to put 5 in. Not quite. You have to read the question. In part B, it simply asks for 30 years. So all I'm going to do is write 30 into this. Now, you just have to put in your calculator. So you can put 20 times E to the power of negative 0.14 times 30. This leads us to our final answer, which we get 0.2999. I like to just round that, giving me 0.30. And it always helps to write grams, the unit. And that's our final answer. So overall, this problem is probably one of the most trickiest things that I've taught in my class. Why? It's because it involves this concept of having an amount and taking the ln of both sides. It's a very complicated procedure, but all you need to do is memorize negative pert. Once you're able to do that, then I think you can basically solve the problem. And that is the end of this whole quarterfinal.